In Chapter 9, Part 5, Drawing a Complex Molecule, we're going to look at drawing something where there isn't just one central atom. So the first thing we want to do is look at these guidelines, and they're really long, but basically it combines the guidelines to determining a Lewis dot structure, how to calculate the formal charge, and how to create a VSEPR structure. And so we can look at all of these and think about how we can use this information. Basically, we want to start with a Lewis dot structure, make sure you calculate the formal charge, and based on the Lewis dot structure, we can determine the VSEPR structure. So if we look at acetic acid, which is the acetate ion, so you do know this, it's the C2H3O2 minus ion. In this case, it's the acid of that. So that would be C2H3O2H. Or there's different ways that you could have written that. But in this case, we see this component. So the way to tackle this is to really only look at one center at a time. Centers can be identified based on the fact that they are usually drawn along the center. Hydrogen is not something with a complex steric center. So we can kind of think about this and say, okay, well, let's just look at this first carbon. We can see that this carbon has 4 bonded atoms. So it's going to have a steric number of 4. This carbon has 3 bonded atoms. Double bonds don't count twice, so this has a steric number of 3. Oxygen has 2 bonded atoms and 2 lone pairs, so it also has a steric number of 4. So you want to start at either the left or the right and basically draw accordingly. So I'm going to start with this carbon. And I'm going to connect each of these items. So we can see that there are 3 hydrogens and another carbon. I'm going to put the carbon here, place my 3 hydrogens here. I place this carbon in the plane because if you add it to a wedge and a dash, it's really hard to continue drawing the molecule. These 4 steric centers I've drawn in red up at the top, you want all of those to be in a line in the plane of the board. So this next steric center has a steric number of 3, so it's trigonal planar. And so we're going to put the double bond oxygen going towards the bottom, the other oxygen at the top. We know that this is also a steric number of 4. And it's going to look like this. So you can add the hydrogen here and our 2 lone pairs. So we can see that we have, I'm going to label them star, square, circle. So for the star, we have tetrahedral as both the electron geometry and the molecular geometry. For the square, we have electron geometry and molecular geometry that's trigonal planar. For the circle, the electron geometry is tetrahedral and the molecular geometry is bent. So one thing I've noticed is students look at this and get overwhelmed by the number of atoms. Attack each stereocenter or each thing that's along the middle independently. Don't try to draw the whole molecule at once. Just look at one at a time. So this one is a little bit bigger. But on a molecule like this, I would be providing you a version of a Lewis dot structure. So you can see here it's a complete Lewis dot structure. So we're going to look at all of these steric centers. So there are more than there were before. But if we look at each one at a time, it will be much easier. So for the nitrogen, we have 3 atoms, 1 LP, steric number of 4. This carbon here is 4 atoms, a steric number of 4. Here, we also have 4 atoms, a steric number of 4. This, we have 3 atoms, a steric number 3. Here, on this oxygen, we have 2 atoms, 2 lone pairs, a steric number of 4. So now we're going to try to look at each group individually and draw that. So I'm going to start with the nitrogen. We know that the nitrogen has a base tetrahedral. So I'm going to put my lone pair at the top, my 2 hydrogens here. Next, we have a carbon that is also tetrahedral. So from here, I'm going to put 1 hydrogen here and then a carbon here, as well as a carbon here. Now I'm going to put the double bond oxygen next. On this carbon, we will have our 4 compounds. Bond angles on that aren't super pretty, but they work. And then we have our oxygen. And it looks like, ooh, put a lone pair here and a lone pair here since I stuck a hydrogen down here. So in this case, what we can see is that each of these are observed. And we can tell that this is tetrahedral bent. We see trigonal planar, trigonal planar, these 2 carbon centers are both tetrahedral, tetrahedral. And this here, this nitrogen, is tetrahedral trigonal pyramid. So again, the bigger the molecule, it's not necessarily any more difficult to calculate or to draw. It just takes time. So only look at one center at a time. Most of the time, we'll find that our centers are in a linear line in the Lewis dot structures that I would provide. So in this case, now we want to look at urea. So we're going to look at our steric centers, and we're going to start with these steric centers right here. So if we zoom in a little, this nitrogen has 3 atoms, 1 LP, which is a steric number of 4. This is 3 atoms, a steric number of 3. We have 3 atoms, 1 lone pair, steric number of 4. So we can draw this molecule starting with one of the nitrogens. I prefer to start on the left. You don't have to. We know that our structure is going to look something like this with these 109.5 angles. So I tend to like to draw my backbone in first. And from here, we've added in our trigonal planar carbon. Now we have another nitrogen. And we're going to see our 2 in the plane at the bottom, the wedge and dash at the top, to where we have our 2 hydrogens and a lone pair. So if we were to look at these, this is tetrahedral trigonal pyramid. The bond angle is less than 109, otherwise known as 107. This here is a trigonal planar. trigonal planar. And it is 120 degrees. So again, no matter the Lewis dot structure that you're provided with, if we take our time, we can draw each one at a time.